All right, we're going to be looking at the review today, so on any of the questions that you need help with, we are going to be looking at them one by one. So our first section that we're looking at, it says to determine if the following lengths could represent the sides of a right triangle. So just to overview, we have a right triangle which has three sides, A, a B, and C. So again, A and B are interchangeable. The thing that has to be in the same place every time is that C, which is across from the right angle, if you notice it points to, and this C is called the hypotenuse. So from there, we're going to be looking at each of these individually. We're going to start with number 1. I'm going to go ahead and zoom in. So if we have to assign a value to each of these, A, B, and C, remembering that C is always the longest. So as we are looking at each of these individuals, we know that 20 has to be C. And then the other two, it doesn't actually matter. C could be, B and A could be switched. So what we'll do is take our numbers and substitute them into our formula. A squared plus B squared equals C squared. So if we have 12 squared plus 16 squared equals 20 squared, we can then simplify from there. So we have 12 squared plus 16 squared gives us 400, and 20 squared also gives us 400. So since we have those equaling each other, we have a right triangle. So again, remember I took this, which was going to be 144, and this, which was 256, and that's where I got this 400, so I skipped over that. All right, so again, looking at number 2, we have to identify our largest. The largest is always C. So we're going to take our formula, A squared plus B squared equals C squared. So 14 and 16, it doesn't matter which one we substitute them into. So 14 squared is 196, and 16 squared is 256, and 18 squared is 324. So what we have to do is take 196 and add 256, and we'll get 452 equals 324. And that definitely looks off right here, so those are not equal, so we have not a right triangle. All right, going across to number 3, we have our longest length, which is 13. And again, 13 is our C because why? Because it's the longest. And then we have to then substitute into our formula, A squared plus B squared equals C squared. We're going to substitute 5 in for A, 12 in for B, and 13 in for C. So 5 squared is 25, plus 12 squared is 144, and 13 squared is 169. So 25 plus 144 is 169. So we see that 169 does equal what's 169. So yes, we have a right triangle. All right, and the very last one in this section, we have looking for our longest. So 0.9, 1.2, and 1.5. 1.5 is C, because why? Because it is the longest. So what we'll do, A squared plus B squared equals C squared. C always having to be the longest. We have 0.9 squared plus 1.2 squared equals 1.5 squared. So what 0.9 squared gives us 0.81 plus 1.2 squared gives us 1.44. And then 1.5 squared gives us 2.25. So what we have to do is add 0.81 to 1.44, and we get 2.25, and we see here that 2.25 equals 2.25, so yes, we have a right triangle. All right, so that is the first section, those 4 questions. Remembering that if a squared plus b squared equals c squared, then you have a right triangle. So our next section we have is to find the interest and total amount for each of the following situations. So that means we're going to either be working with I equals PRT or the A equals P parentheses 1 plus R to the T power. So let's go ahead and look at our first one. So we have Tony deposits $650 in a savings account earning 7% simple interest for 4 years. So we have a simple interest, so that means we're going to use the formula I equals PRT. And in our formula, we have a principal amount of $650. We have a rate of 7%, and we have a time of 4 years. So we can put each of those numbers into our formula. So we have I equals 650 times, again, this rate has to be as a decimal, so we're going to have to divide by 100, which will move our decimal point 2 places to the left, giving us 0.07. And our time is already in years, so we can just put that into our formula. So when we solve that, we get 650 times 0.07 times 4, 182 is our interest. So that is the number that is going to go right here, 182. So the other thing we have to find is our total amount. So Tony deposited $650, and then at the end of 4 years, he earned an additional $182. So to find our total amount, we're going to have to take the original 650 and add our principal 650 plus our additional interest that we earned. So 182 plus 650, we get a total of $832. So that's what we're going to be doing on that one. So A stands for total amount, right? A total amount. All right, we're going to number 6. So Blake invests $2,000 in a certificate of deposit that earns 3.1% interest compounded annually for 12 years. So the biggest thing we're trying to figure out what type of interest. So we're looking at compounded annually, which tells us that we're going to be using the compound interest formula, which is as follows. So what I need to do is find these individual things. So our first, our principal amount is $2,000. Our rate is 3.1%, and our time is 12 years. So the only thing we need to change is this 3.1%. We have to divide by 100, which moves our decimal point 2 places, which gives us 0.031. And the other numbers are just fine. We have years already, and we already have our money. So what we'll do is take A equals 2,000, parentheses 1 plus 0.031, to the 12th power. And when we simplify that, we'll get 2,000, parentheses 1 plus 0.031, parentheses raised to the 12th power. We get 2,884.92. So we always round to 2 decimal places with money. So that number is the one that's going to go right here, because this is our total amount, 2,884.92. And in order to find the amount of interest that we have earned on this account, we're going to have to take our amount, 2,884, and subtract. So to find interest, we have to subtract our principal amount, which was 2,000. And that number is going to go here. So let me make sure that's clear. So we're going to take this number right here is what goes there. And then whatever we get in this space is going to go in our interest. So when I subtract 2,000, I get 884.92. Alrighty. So now we have AJ borrows $12,000 to buy a car that charges 3.5% compound interest for 30 months. All right. So compound interest. So that means our formula that we're going to use, A equals principal times 1 plus r to the t power. So from here we can get our principal amount. The loan was $12,000, so that's our principal. Our rate is 3.5%, and our time is 30 months. So it has to be in years. So 30 months, in order to turn that to years, we have to divide by the number of months. So we're going to have to divide by 12 months to turn it to years. So 30 divided by 12, we get 2.5 years. So that's the number that we're going to want to put in our formula. So we get A equals, now I'm just substituting, 12,000 times 1 plus, again, sorry, with the 3.5 have to divide by 100, so that's going to be 0.035 raised to the 2.5 power. So when we do that, we get 12,000, parentheses 1 plus 0.035 raised to the 2.5 power. And then we come up with $113,077.72. So this number here is our total amount, and that goes here. So $13,077.72. And then in order to find our interest, we're going to have to subtract our total, our principal amount that we borrowed. And then what we get here, we will put is the interest that we earned. So we're going to subtract that 12 original loan, and we get $1,077.72. So that is our number here. All right. Number 8, Martin deposits $700 in a savings account earning 4% interest compounded annually for 5 years. So our formula that we're looking at is compounded annually, which leads us to the formula A equals principal times 1 plus r to the t power. And we are going to then find so we're looking at our principal, which is 700, our rate, which is 4%, which we know have to turn to a decimal by dividing by 100, and our time, which is 5 years. And we don't have to change that since it's already in years. So what we'll do is substitute 700 times 1 plus 0.04 to the 5th power. So 700 parentheses 1 plus 0.04 to the 5th power. We get our total amount is $851.66. So this amount here is going to go here because it's A equals, so 851.66. So again, in order to find our interest, we're going to have to subtract our principal amount, and we get 151.66. So that is the amount. This amount we get is going to go here. 151.66. All right, Betsy borrows $22,000 to buy a car that charges 5.5% simple interest for 48 months. So having to figure out, we're looking at simple interest. So that means we're going to look at the formula I equals PRT. So let's find the values that we need. We know that our principal amount is $22,000. Our rate is 5.5%, which we have to divide by 100, 0.055. We move that decimal place twice, dividing by 100. And our time is 48 months. But here's our problem. Months needs to be years, so we got to take 48 and divide by 12 because we have months and months. So 48 divided by 12, you will get 4 years. So that is the number. This is the number we're going to put in for our time. So when we find I equals 22,000 times 0.055 times 4, when we multiply those out, times 0.055 times 4, we get 4,840 is the interest. So this amount right here is going to go right here. And then to know how much total, so this A, again, remember, is our total amount. And so in order to find the total amount, we're going to have to add back the principal that we borrowed, which was $22,000. So then whatever we get once we add those two together, which is 26840, that number is the total amount that Betsy has to pay back. So the 4,840 is just the interest that the car loan is going to cost, the interest. And then at the end of 4 years, the total amount that she paid for the car is the $26,840. And the last interest question we have, Kylan buys a $20,000 life insurance policy that pays 4% compounded annually for 5 years. So we have compounded annually, which leads us to the formula A equals principal times 1 plus R to the T power. And then we're going to go ahead and pull out the numbers that we need. We have the principal. We have the rate, which is 4%, which again we have to divide by 100, so it's going to be 0.04. And we're going to have the time, which is 5 years, so we're good there, times 5 years. And when we substitute those in, we'll go 20,000 parentheses 1 plus 0.04 to the 5th power. So 20,000 parentheses 1 plus 0.04 raised to the 5th power. So that gives us A equals $24,333.06. And this amount here is what we're going to put here. So that's the total amount that the life insurance policy will be after 5 years. But that's not the amount that of interest that he gained. He didn't gain $24,000 in interest. The amount that he gained is going to be figured out when we subtract the 20,000 original. So that leaves us with $4,333.06. So that is our ending interest amount. So there's our interest questions. So when you're looking for A, it's the total amount, and we're looking for I, it's the interest. So let's go ahead and looks like we're going back to the finding the missing side length. So we're looking at A squared plus B squared equals C squared. So as we look at this, we're going to have to make sure we're identifying the correct missing side. So we have our right angle, which is always pointing to C. So with this one, we're going to take 13.4 squared plus 4.6 squared equals C squared. So 13.4 squared equals 179.56 plus 4.6 squared is 21.16 squared. Oh, sorry, not squared. We already squared it. And then C squared. So when I add those two up, 179.56 plus 21.16, I get 200.72 equals C squared. So again, we're only looking for C. And this here says C squared. So we need to get rid to unsquare it. So we have to take the square root of both sides. So that will leave us with C on the right and then 14.16, which would round to 14.2. And that is your answer for C. All right, on number 12. So we have our right angle that always points to C. So that means we're looking for either A or B. And again, it doesn't matter. So we have A squared plus B squared equals C squared. So we know that I just chose B. So let's take 3.2 squared is A plus B squared that we don't know. And C is 5.5, and then we square it. So 3.2 squared is 10.24 plus B squared equals 5.5 squared, which is 30.25. So then we have to isolate. So B is what we're looking for. B is right here. But we have to isolate this. So we're going to have to subtract 10.24 from both sides. And we will get B squared equals 20.01. And since we just need b, and this said b squared, we're going to have to take the square root of both sides. And when we do that, we end with b on the left, and the answer on the right is going to be 4.5. 4.5. Okay, number 13. So we have our triangle here, and again, trying to find which side we're missing, remembering that our arrow always points to C. So that means maybe we're missing A this time. So if we have A squared plus B squared equals C squared, we know A is missing, and then this is B, and C is 13.8. So if I go A squared plus 10.5 squared equals 13.8 squared, then we go ahead and 10.5 squared is, so we have A squared plus 10.5 squared, which is 110.25, equals 13.8 squared, which is 190.44. So I'm going to then subtract 110.25 from both sides. On the left, that becomes 0, and then we'll be left with A squared equals 190 minus 110.25, which is 80.19. So then we're looking just for A, right? So we need to unsquare this by taking the square root of 80.19, and we get A equals 8.95, but we're supposed to round to the nearest tenth. So since 8.95, so this 9 would round up, so we're going to have to round this to 9.0. So that is your answer there. So sometimes you're looking for A and B. So if you notice from these two examples, I have A and B are interchangeable. So as long as they are assigned to one of those. All right, we got a couple more of these. So we have this pointing to C always. So we have A squared plus B squared equals C squared. So we're going to have 2.5 squared plus 2.8 squared equals C squared. And then we have to square those. So 2.5 squared, 6.25 plus 2.8 squared, which is 7.84 equals C squared. So then we're going to take 6.25 and add 7.84. And that leaves us with 15.68 equals C squared. And since we're just looking for C by itself, we have to take the square root of both sides. And then that leaves us with 3.95. But then again, we have to round to the nearest tenth. So this right here would round up. So we're going to look at 4.0 equals C. All right, number 15, we have a angle pointing to C again. So we have A squared plus B squared equals C squared. So we have A and B again. So the only one we are going to substitute, 8.8 squared plus 6.6 squared equals C squared. So 8.8 squared is 77.44. 6.6 squared is 43.56. and then we don't know c squared. So we're going to add those two up on the left, 77.44 plus 43.56, and we're going to get 121 equals c squared. And then we're going to take the square root of both sides, and we'll get c equals 11. All right, the last Pythagorean over here, we have, remembering that this is pointing to c, so 11.6 is c, and then these two are interchangeable. So we have a squared plus b squared equals c squared. I'm going to substitute 6.1 in for the a, plus b squared we don't know, and then we have 11.6 squared for c. So 6.1 squared is 37.21, plus b squared we don't know equals 11.6 squared, which is 134.56. And then to get b by itself, we're going to subtract from both sides. On the left, that becomes 0, and we're left with b squared equals 134.56 minus 37.21, and we get 97.35. And then we're going to take the square root of both sides. On the left, we'll be left with b, and on the right, we will get 9.86, which would round to 9.9 to the nearest tenth. All right, so there's those Pythagorean questions. And now we're going to look at number 17. So we're looking for the length of each line segment shown on the coordinate grid. So what we've learned to do in class is, rather than counting, we're going to turn each of these into right triangles. So here we have 3 separate right triangles where we can so we have 3 separate right triangles that we can find. So what we're going to have to do, I'm going to start with this one up here. So we have this side length, which is going to be 2. And then this side length, making sure to count each of the individual boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So on this one, we are looking for c. So we're going to have 2 squared plus 9 squared equals c squared. So we have 2 squared plus 9 squared, which gives us 85 equals c squared. And then take the square root of both sides. Square root of 85, we get 9.2 equals c. On this other one, we have 1, 2, 3, 4 on this side, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 over here. So again, our right angle is pointing to C, so we're looking for the hypotenuse again. And so we will have a squared plus b squared equals c squared. So we have 4 squared plus 13 squared equals c squared. So 4 squared plus 13 squared, we get 185 equals c squared. And then we're going to take the square root of both sides, and we get c equals 13.6. And that is that one there. And the last one over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 here. And again, we're looking for, again, we can see that this is pointing to C, so we're looking for the hypotenuse. So a squared plus b squared equals c squared. So the 13 and 10 are interchangeable, so we could do 13 squared plus 10 squared equals c squared. So 13 squared plus 10 squared equals 269 equals c squared. And then we're going to take the square root of both. So take the square root of this, which will give us c. And then the square root of 269 is 16.4. So that is where that will go there. And number 18. A tree struck by lightning broke at a point 12 foot above the ground as shown. What is the height of the tree to the nearest foot? So they give us, we're looking for C. So if you see, we have our right triangle here. And so that means if we have a squared plus b squared equals c squared, we don't know c, but we can put in 12 squared and 39 squared for our a and b. So if we have 12 squared plus 39 squared, we get 1,665 equals c squared. And then we're going to take the square root of both of these numbers. So on the right, we get c, and the square root of that number will be 40.8. So that is what c equals, 40. Oh, so it says to the nearest foot. So this is going to round up. So we actually have c equals 41 when rounded properly. So this is 41. But the question says, what was the height of the tree to the nearest foot? So we know that if we were to stand this up, so we have 12 foot here, and the tree was broken, so we have 12 feet here, and we have 41 feet here. So we're going to have to add 12 plus 41, because that's the length. So this, because this right here, this is tree, and this is also tree. So we have to add both of those up in order to get 12 plus 41, and we're going to get 53. And this says centimeters, but it should say feet. So that's one tricky way that they can ask you to try and trick you to finding the wrong answer. And the last one we have is the figure could be used to demonstrate the Pythagorean theorem. Complete the figure with missing areas and side lengths. So we have 144 centimeters squared. So that is the centimeters squared. This is the area. So in order to unsquare something, 144 centimeters squared, to unsquare something, we have to take the square root of 144, and that will give us 12 centimeters, because if you think about it, 12 times 12 is that 144. So on this side, if we're looking at this square, we have 16 times 16. We get 256 centimeters squared. So here, 16 times 16. And the last one, we have 400 centimeters squared. So again, this is the area, but we're asking for the side length of one side. So we have to take 400 centimeters squared and unsquare it by taking the square root, which will give us that each side length is 20, because 20 times 20 gives us 400 centimeters squared. All right, so there is the completed review. Hopefully this helps, and good luck on your test tomorrow.